According to few historians, typhoid fever was responsible for a widespread plague in 430 BC in Athens, which proved fatal for one-third of the population, and in 1600s, an English colony in Virginia saw devastating effects, proving to be fatal for 6,000 settlers, resulting in the elimination of the whole community. It has devastated entire communities, with recurring, widespread outbreaks across the world. Typhoid bacteria spread through contaminated food and water. Those afflicted with typhoid fever suffer from head and stomach aches, high fever, constipation or diarrhea, and in the worst extreme cases, even death. Every year, an estimated 200,000 people die of the typhoid fever. A majority of the high burden of typhoid is borne by region Indian subcontinent. India has a long history of battling this life-threatening fever that has brought a significant economic burden on the country. This disease affects all age groups, of which the children are most at risk of contracting the deadly disease. The lack of distinctive symptoms of typhoid fever makes it challenging for early and accurate detection of the disease. Additionally, in developing countries, the increasing antibiotic resistance has become a threat, leading to the requirement of an alternative approach for the treatment of typhoid fever. The good news is that typhoid is a vaccine-preventable disease. Vaccination has become the most effective solution in the management and eradication of the disease. Routine vaccination can contribute to reduction in cases and save millions of cases every year. Among the available typhoid vaccines, plain VI polysaccharide typhoid vaccines, however, fell short among the available typhoid vaccines. Plain VI polysaccharide typhoid vaccines, however, fell short in two critical ways. 1. It failed to provide long-term protection. And 2. It cannot be administered to children below the age of 2. With new scientific breakthroughs in the field of vaccines have enabled newer possibilities, typhoid conjugate vaccines have emerged as the vaccine with the potential to overcome challenges that have impeded the uptake of earlier vaccines. The safety, efficacy, and long-term protection provided by the vaccine has prompted the World Health Organization to recommend TCV to be included in routine immunization schedules, starting from 6 months of age in countries affected by the infection. With a legacy spanning over 50 years in making high-quality vaccines affordable and accessible, Biological E Limited is working towards the unmet needs of the people in fighting this illness and ultimately towards the eradication of typhoid fever. With our commitment to improving healthcare and the quality of life, we channeled all our efforts to develop the most advanced typhoid vaccine. Biological E's TCV vaccine is a new generation vaccine against typhoid disease, tailor-made to cater to the demands of evolving generations.
BE has drawn up impressive pipeline which is second to none in the industry. TCV is significantly superior and most modern compared to its previous generation polysaccharide vaccine.
Our TCV vaccine is the first of its kind in the world, and the VIPS derived from the friendly, non-pathogenic bacterium Citrobacter frontae, which is immunologically indistinguishable from VI polysaccharide of Salmonella typhi and yet devoid of endo and exotoxins. The CRM197 carrier protein used in our vaccine is a novel non-toxic conjugate protein that does not require chemical detoxification.
CRM197 as a carrier protein offers much better safety compared to tetanus toxoid in terms of manufacturability, handling, downstream purification and detoxification of the product. The CRM197 not only supports typhoid conjugate, in future polysaccharide conjugates also we could use this protein.
The preparation of the size-controlled VIPS, verified via advanced analytical tools of HNMR and ion exchange chromatography, making it precise and technologically advanced vaccine. Biological E has partnered with GVGH, GSK Vaccine for Global Health, for licensing CRM technology.
BioE took over the product development activities in 2014. The antigenic VI polysaccharide is actually manufactured from non-pathogenic Citrobacter frundi bacteria, a characteristic feature of our vaccine. Significant innovative efforts led to development of a patented alcohol-free manufacturing process for VI polysaccharide, and specific chromatography steps yield VI CRM conjugate with very low free VI polysaccharide.
The in-house R&D team further improvised the CRM and used the VIPS manufacturing process to make the strain safer and show higher efficacy.
At this momentous occasion of TCV launch, we miss late Dr. Akshay Goel, who has been the scientist-in-chief behind this particular product from concept to almost commercialization. Today, we really miss him.